Functions. I recognize that most of you are probably watching these videos back to back, and so I'm trying with my whole soul to not just start every video saying, "Hey everybody," or "Hi everyone." Welcome back, because it's probably not been very long for you. So every once in a while you'll get a very creative intro from me as I try to keep things exciting and fresh. And welcome officially to chapter 4. If you've been watching these back to back, I might recommend that you just take a bit of a break as a breather, kind of digest some of that information. It's a lot of information if you've never done any of this before, which many of you haven't. And we're just getting into the programming. And really, if we were in a regular term, it wouldn't be happening so quickly. But because we have to squish this all into 6 weeks, we got to get through a lot in this first week. So we're making huge strides just in this little bit of time that you've been working on the course already, where we're learning lots of the language of how we talk about programming. We're actually writing programs and processing already. We're getting the computer to do things we want. We're figuring out how to kind of interpret some of the errors that we might be seeing. And it's a lot. But I will say for this chapter, we've actually been doing this since the beginning. And you probably could tell, because oftentimes I was using the language functions already in some of the previous videos. But when we talked about encapsulation, we were talking about functions. And when we were using those commands to draw lines and squares and circles in processing, we were using functions. They just weren't functions that we had defined, but it doesn't matter if we define them or someone else does. They're still functions at the end of the day. And it truly goes back to that whole principle of encapsulation, where you're taking related tasks, wrapping them in something that has a name associated with it, so that we can just tell the computer to go back to that set of instructions and repeat it any number of times that we want it to. Functions are not only great for computers, they're great for our hands because they save us some typing. We're not typing out the same things over and over and over again. They're also really good for documentation in our code. So you'll notice when we were reading the textbook, we gave really informative names to our functions. So they told the users what those functions will probably do. And we talked a little bit in this chapter too about how we can add comments in to tell users even more information about what's going on in our code. So not only are we communicating with our computers, but we're also communicating with people who might use our code later on. Whether it's us, or maybe we work for a big company and it's going to be somebody else if we work for Microsoft and we're building libraries or who knows what, right? So it's all starting to lay those fundamentals about how we do programming. And really with this one, I want you to understand that you have been doing this whole time, all right? There's some interesting things that happen with functions that we're going to work through in this set of exercises. And I'm excited for you to kind of discover them with me here. So we're going to go through this first demo here. We have a function that's defined. It's called secret. So what's this def thing here? Do you remember from the textbook? If not, maybe you want to go read that section again. Def is a special word for our computer that gives it a hint of what's to come. It's saying, hey, stupid computer, pay attention. We are doing something very special here. We are defining a function. And the next few lines of code are going to be associated with that function. And you need to remember that. So if I tell you to use this function, you know where to go. So def is what we would call a keyword. It's often going to be highlighted in a different color. So when we're in processing or when you see it on the slides, it's followed by the function name. So we would give it that function name. And then we always have these brackets, which may or may not have different things called parameters in them or arguments. Again, if you don't remember what that is, check the textbook. And then this colon. And that colon is just there to communicate with the computer to say everything after this that I've indented is going to be part of this function or attached to this function. So in this case, we have 2 actions attached to this function. And both of them are calling other functions, which we can do. And they're calling, in this case, the line function from processing and getting it to draw lines at these different coordinates. Pop quiz where the points don't matter. Is this size command part of our function? No, it's not. And the reason we know it's not is because it's not indented to the same level as these two line commands. So this is actually just a tab, this indentation here. You could also use spaces, but you just need to be consistent throughout your code. So if you're going to become a tab programmer or a space programmer, you just got to be consistent. Okay. I like tabs because it's one key that I press and then I don't have to worry about it. I have colleagues though that prefer spaces, you name it. Usually once you start working for big companies, they'll be defining if you're using tabs or spaces. But so it's, if this was tabbed over, even if there was a white line in between, it would be a part. But because it's not, it's outside of our function. So only these two commands, you can tell, because they're lined up right here, are part of the secret function. Now when I look at this, I know it's drawing lines. In my brain, I look at those numbers and I have zero idea what those lines actually would look like. So I'm probably going to want to put it into processing and see what it does. So I'm just going to bring over my processing here. I'm going to leave it over to the side just so that I can have the slide up at the same time. And I'm not going to copy and paste. One, because sometimes you get weird hidden characters. But two, and what I would recommend for everyone in this course, is to try to not copy paste code yet. What you want to do is type it out to start building up that muscle memory, because that's going to help you remember things when you're doing assignments and exams and code labs. You'll, oh yeah, I remember how to draw this line. Oh yeah, I remember how to define a function. So we're going to type it out. We start with def, our special keyword. Oh, and why is this like this? Let me see what I can do here. Whoopsie. What have I done? I'll just make a new one. The global fixer. There we go. Def, our function name, which is secret, open bracket, close bracket. So in this case, that means there's no parameters for this. Our fancy colon, so that the computer knows what we're doing. It's defining a function. And you'll see processing is really nice to me and automatically indents that over. You can tell that processing is a space type of it uses spaces for its indents instead of tab. You can change that into preferences if you like. I'll just leave it because I'm not that particular. Well, I do prefer tabs. If it's just automatically making them spaces, I'm not going to argue. Now we'll do our two line commands. And so you can see that these are functions that are defined by processing and they get highlighted in that blue color there. That tells us that we're using a processing function instead of one that we maybe have defined on our own. So we have line, we have 40, we have 30, we have 75, and 60. And then another line that goes from 75, 30. So remember, these are X and Y coordinates. This is our first X and Y coordinate. And then our second one would be 40 and 60. And then I have to backspace to get rid of the tab. And I put size 300, 300. And that's setting the size of our canvas. Now, what if I hit run? And I want to see what these lines make. Why did I get an empty canvas? I thought we were drawing lines here. My size seems to have worked. But why would there be an empty canvas there? I'm just hearing it through the wavelengths right now. Everyone yelling at me. Kim, it's because we only defined the function. We didn't call it. You are correct. So, this is a bit of a trick demo. In essence, all this code is doing is defining this function, telling the computer what the instructions are if somebody were to ever call that function, and then setting the size of the canvas. If we actually wanted to see what that function created, we need to call it. And to do that, we just type the name of the function And then since this one has no parameters, we just put the opening bracket and the closing bracket with nothing in between it. I'll get rid of this canvas. I'll run it again. Ta-da! It draws an X. Now, if I'm looking at these numbers, I will be 100% honest with you. I would have never got that. It would have taken me a lot of brain power to figure that one out. I would have way rather just put it in the computer and had the computer tell me. So if you're the same way, it's all good. So see, we defined it here, and then we called it here. And we can call it any number of times. In this case, because there is no parameters, nothing will change every single time we call it. It's going to just draw an X in the exact same position. So it might not look that different. It might look exactly the same. Okay, you can see it's a little bit thicker. So like the lines are like, oh, there's more than one here. But it looks effectively the same, all right? It's a bit of a trick question. Fun with functions. So remember, we always have to define a function though before we use it. It's just like we always would need the recipe before we go to cook something. We need that set of instructions in order to do the tasks. So does the computer. If we try to call this, for sake of argument, without having any of this here, and all I'm going to do to get rid of it in this case is I'm going to comment it out. See how it turns it gray? So I'm just putting that little hashtag symbol in front of the lines that I want the computer to ignore. That's just telling the computer, these aren't for you, they're for the human reader. In reality, what I'm doing is conveniently getting it to ignore it just with one character. And now if I rerun this, where is any of my stuff? Nothing. It's giving me a hidden error. So effectively, I'm calling something and it's not doing anything because that function doesn't even exist. If this was a brand new session, it also might give me an error at the bottom saying secret was not defined, but some of the other programming languages are a little bit more persnickety about those types of things. All right. So we have an exercise here that I want you to do on your own. So we have 3 functions defined. So what you'll do is type out those functions into processing. And then we want you to do all of these different scenarios. And the solution code is posted on the course website, but you'll use these functions, so you'll just be calling them, to draw these different types of scenes. So a moon with the flag planted on its surface, a moon with 3 craters anywhere on its surface, and then the final one, a moon with 3 craters, the flag in the center of one of the craters, and the flag being partially hidden by another crater. So you might have to do some figuring on some graph papers, drawing out to figure out what those coordinates are. You can also try some different numbers, run things a bunch of different times to see if you can get it to work. And you'll note for calling these different functions, so once you type them in, just like we did here, underneath, you just type in the name of the function. So this in case, we just say draw moon with the 2 brackets and nothing in between because there's no parameters. For draw crater, we wouldn't put X and Y in between. We'd replace those with the coordinates we actually want the center of that crater to be at. So you'll see that those get values from X would get put into this part with this call to eclipse here, and the value to Y would get put into this call to ellipse here. So you can play around with that a little bit, okay? All right, now here we did actually this one here in the textbook where we drew a circle, or did I do that actually last video? I think I did that last video. I just didn't make it into a function. So let's make it into a function. We want to make a function called draw circle, which has parameters x, y, and d, and draws a circle centered at x, y with diameter d. And then I'll leave B for y'all to do on your own. Oops, there we go. So when we're defining a function, we need to tell the computer, prepare yourself, we are defining a function. And we do that with the def keyword. We then will put in our function name, which in this case we need it to be draw circle with our brackets. And then we will always have a colon. And after that, we're going to have some body of our function. Now in this case, our question asks us to add parameters into this function. So we want to add x, y, and d as a parameter. All we need to do is inside of these brackets up here, where we have our function name, put those letters x, comma, y, comma, and d. What this does is it effectively says, we are creating these things called variables. And we'll get more into that a little bit later. But what they do is they just give a name to some sort of value that we'll define at a later date. And it's almost like a bit of a placeholder where we can say, okay, I don't know what value I want this to be quite yet. I know I will define this value once I run it. And so at runtime, whatever number I give you, use it wherever I put an X in this function, or a Y, or a D, okay? And so here, for drawing circles, we know we use the ellipse command, and that takes an X coordinate, which would be our X parameter, a Y coordinate, which would be our Y parameter, and then our size all around. And if we wanted a circle, we just make it the same size for both of the next parameters. So D, comma D. If we wanted to get really fancy, we could change that to be a radius. Just a second. By doing some math there. I'm not going to do that in this example. We can do it a different time. Now, if we were to run just this, would we see anything? No. We've just told the computer that these set of instructions exist and that it should know about it. A very important function over here. It needs to know. If I want to make sure that this function is working as I expect, I need to call it. And so I wouldn't do this, right? And why wouldn't I do this? That looks like it could be right. If I do this, remember what we're doing with these tabs. We're saying that then we're calling it within the definition. And it's actually not going to run that. It's just going to save that as an instruction. So we need to remove the indent, and then I like to put an extra line break in between, which is just an enter key, just so that it's easy for me to see. The computer doesn't care. But the line break is important. If we do it out here at the same level that we have def, then it knows, okay, I got all my instructions here. Ah, now you want me to go find those instructions and actually do it. Excellent. And we're going to take those values that you weren't quite sure what they were going to be before and give them these numbers. So X is 30, Y is 30, and D is 30. And if I run that, I get a circle. So satisfying. And now if I do this again, let's leave this one here. I'm going to copy that. I'm going to paste it. And I'm just going to change these to be 100. Maybe I'll make this one 50 and 42. Actually, let's make this even larger. Ooh, what number would I like? 78. Sure, why not? Now when I run it, oh, I see one circle, and then I kind of see a half of a circle, and that's a little weird. You might be wondering why. It's actually because my canvas size isn't big enough. So if I want to fix that, I need to go into the beginning of all of this section here where I'm running actual commands and just update that to be a little larger. So let's make it 300 by 300. And now we'll run it. Ah, much better. I can see both of my circles. This is excellent. So just that size command made us go from something that looked like this to something that looks like this. My coffee is done. This is what the problem is. Oftentimes when I'm doing things like this, you'll want to add in comments. And so we talked about comments too in the textbook. Even if we do a main part of the program, this just gives us an indication that here we're defining things and here we're actually running them. And if you'll remember from the textbook, we also talked about something called a docstring. A docstring is a special kind of comment for human users that tells us what the function actually does. And in this case, and for a lot of your assignments and a lot of exam questions and stuff, it's going to seem really silly writing docstrings. And it's because this part here, let me just move this over, where it says takes parameters and draws a circle centered at X and Y. This draws a circle centered at X and Y with diameter D. is exactly what you would put for your description of what the function does. So draws a circle at x, y with diameter d. And then you would have your definition of what your inputs are. So x would be your x coordinate. Y is your y coordinate. And d is your diameter, right? So you have all of those kind of things laid out. Sometimes they can seem really, really obvious, but they're typically a little more obvious just because of how courses are structured. When you get into kind of real world work, they're a little less straightforward, but it's good practice to get into that habit right now. And you'll see that even though we added those comments, if we rerun this, it's not going to change anything with our actual code that's output or our canvas that we got on the output there, right? So I'll get you to try to draw this or to write this function and use it for drawing concentric circles. It's a bit of a more tricky one, but it'll be a fun one to do. One hint is that if you don't see all three circles, make sure you're drawing the largest one first. And that's the only hint I'll give you for that one for now. So I already gave you a little bit of an overview of comments. So single line comments, reminder, are the ones that start with the hash symbol. And in this exercise, what it's doing is asking you to add in appropriate single line comments into this code. So when you look at this code right now, okay, it wants us to draw something. I'm not sure what. And what I would actually do to figure out what this was drawing is I would take that code, copy it into processing, and then call it and run it and see what it does. And you can even do it just like few lines by few lines to kind of try it out and see, okay, what do these three circles generate? And what does this other line generate? And what is the picture that it's trying to paint here? And then you'll group the different commands together with single line comments. I'll let you do this one yourself and then just check the assignment or the lecture exercise solutions to see if you got it right, all right? And same with this docstring. So we already did a docstring for our draw circle function, and you need to do a docstring for the draw concentric circles function. So remember, it should be those triple double quotes, should have a brief description about what the function does, and then a description about what each of the parameters are. And so in this case, the parameters are x and y. And an example of a correct solution for this is in the lecture exercise solutions. But again, yours might look slightly different, and we would expect it to if you're making comments and things like that. That's one of the things that is usually different between people's solutions is their comments. Everyone's going to add their own little flavor to it. So it doesn't have to be identical to ours, but it should have the same kind of idea or flavor. All right? Well, happy coding. Best of luck.